number 16, we have a situation where guys stand on a stationary, that's important, 210 kilogram floating raft. So if the whole thing is stationary to begin with, that means its momentum is 0. So if we do this problem as a conservation of momentum problem, which we will find out that the final momentum, which would be the sum of his momentum forward and the raft's momentum backward, have to equal 0. So in other words, they have to be the same. So basically what we're saying is that the momentum of the swimmer plus the momentum of the raft beforehand have to equal the momentum of the swimmer plus the momentum of the raft afterward. I'm using primes here, but you know I'm going to use U's for after collision. It's not a collision per se, but it's still a conservation of momentum problem. So we got mass of the swimmer, velocity of the swimmer, plus mass of the raft, velocity of the raft. But we know all that equals 0 because the whole thing is stationary to begin with. It's got to be equal to mass of the swimmer and the afterward U we use for after the collision or after the event, velocity of the swimmer plus mass of the raft afterward velocity of the raft. We know that together these have to equal 0, so we can just come down here and we can say that mass of the swimmer, velocity of the swimmer have to be equal to the negative of the mass of the raft, velocity of the raft. Actually, we'll end up flipping that around because we know the mass of the, well, let's solve for the velocity of the raft, which is what we're asking for, the recoil velocity of the raft, provided there's no friction. Now I know that the water would probably grab the raft, right, a little bit more than we're allowing for here. It's more like if you stepped off a skateboard is what we'd be solving for here. So UR is equal to negative MS US over MR. So here we get sort of another way of thinking of that is the inverse ratio of their masses, right? MS over MR times US. Okay, and that's negative, and that's UR. All right. So we have the mass of the swimmer is 55 kilograms, 210, 4.6. All right, so we get negative 55 kilograms over 210 kilograms times, I already forgot the velocity. What is it? 4.6 meters per second. 4.6 meters per second. And of course, these are going to cancel out. The units there, again, we're looking for the velocity of the raft. Notice it's going to be in the negative direction. That makes sense. If he steps off this way, he's got to push this way on the raft. All right, so UR is equal to 55 over 210 negative times 4.6 meters per second. Again, these cancel out the units, mass units cancel out, so we get negative 1.2 meters per second is the velocity of the raft in the opposite direction. And that makes sense because since it's more massive, it would have to have a smaller velocity to have the same momentum in the negative direction as the swimmer does going in the positive direction.